name is Nishtha. I originally come from India. I finished my PhD in India and I moved to the University of Michigan about 2 years ago as a postdoc. And I was hired to work with the solar corona model within the space weather modeling framework. So that's the skill that will be used in the Solstice project as well. The idea is to be able to simulate the solar corona and the environment between the sun and the earth, in which the coronal mass ejections will be introduced, and we can study the propagation of these geomagnetic events that affect the space weather. So I think it started with high school. I enjoyed physics, and then when I went into my bachelor's and my master's, I specialized in astrophysics, which was really interesting, and it was quite fascinating at the time. And when I started my PhD, we found a good project in solar physics, so that kind of became more specified, and I did some solar physics. And then when I moved here, I'm still a solar physicist, but it's kind of broadened, and I do simulation and computational stuff. And previously I used to do theoretical physics. So it's interesting to me because it's like at the point when I started, it wasn't that explored. And now there's a lot of work that is being done in this field, and it's really exciting. So that's what I enjoy. I think it's not necessarily the same every day. There are days when you're really productive. There are days when nothing works. So it's kind of a balance, I think, between the two. But in general, I get to work. I start with a list of what all things that I need to do or I need to finish that day. And then I meet with my professor, my supervisor. We discuss what my progress and what I've done so far, and if he has any insights or if he has certain things that he wants to be done, I kind of work on them. And yeah, by evening I come back and that's it. It's essentially simulating the environment between the sun and the earth. Okay, and what I started on working here was using a magnetohydrodynamic code which simulates this environment. So it has all the physics of energy, energy transitioning and everything. And what we find is, what is interesting is that we looked at all the observations from instruments or spacecrafts that take the data, and we compare with our simulations, and we find that there's good agreement. So essentially the idea is that we are able to replicate or simulate the actual realistic solar environment. I think patience. I think you need a lot of patience. You should listen to people who have been in this field for a long time, and you should always be ready to learn, because everybody has a different outlook or an insight into a problem. So there's always opportunity to learn. And yeah, don't get frustrated too much. So I'll answer the second part first. For what I'm particularly involved in, I think I'm really excited to see the coronal mass ejection simulations. So just to explain, CMEs or coronal mass ejections are these huge blobs of plasma that erupt out from the sun. Okay, and that's what causes various effects in the geomagnetic space and affects the space weather. So those are what I'm interested in, and I am looking forward to see how we can do those simulations and how close to reality or how close to the observations do we get those results. Solstice, I think it's a huge undertaking, and I think it will be a huge step forward into using machine learning and these computational tools for flare predictions, for CME, for understanding the physics behind the initiation of coronal mass ejections, and being able to see how it affects the Earth and the space around the Earth. So all these impacts, like the terrestrial impacts, as well as how it actually starts off near the sun. So it kind of covers the whole range. I think that's it's really challenging and it's really exciting to work on.